Now for this last problem, I'm going to use integration by parts to find the antiderivative of natural log x. Now remember, natural log of x is the antiderivative of 1 over x, or with an absolute value involved. But what about natural log x itself? What would be its antiderivative? And it turns out we can use parts to figure this out. It's a little tricky, but the way it works is we can use the fact that we know the derivative of natural log x, and that we can sort of see that as becoming simpler. And then we can simply let my dv be the dx. So let's write that out. If u is natural log of x, then my du, since I know its derivative, even though I'm looking for its antiderivative, I start by using the fact that I know its derivative, 1 over x. Likewise, if dv is simply dx, you can think of this as dv over dx equals 1. Then what would my original v be? Well, the derivative of 1 comes from x itself. So let's make those substitutions. So the formula says u times v, natural log x, times v is x, minus the integral of v du. And well, that's handy because I see an x and a 1 over x, and those just cancel with one another. So I can integrate this directly. I can leave this as, I might write x natural log of x minus, what do I have left? I'm integrating dx, and that it just gives me x itself, plus c. And there's my answer. The integral of natural log x is x natural log x. The integral of natural log x is x natural log x minus x plus c. And since that's such a short problem, let's check our work. You can always check your work after an integration problem if you have time to see that you did the correct thing. And if I take the derivative of x natural log x minus x plus c, of course, the constant goes away because it's by itself and we're taking the derivative. And we'll have to use a product rule. And if you ever check an integration by parts problem, you'll be using the product rule to check it because integration by parts is the opposite of the product rule. And we'll do the second times the derivative of the first plus the first times the derivative of the second, and then the minus x becomes minus 1. And of course, we get lots and lots of canceling. The x cancels with the x here. Then we have 1 minus 1 cancels. Anything times 1 is itself. That is indeed natural log x for the derivative. So we did indeed find the general antiderivative for natural log x.